I'm looking at a section of marsh. We've got a whooping crane, we've got great egrets, tricolored herons, great blue herons, yellow legs, willets, shorebirds. Those are the pieces of the ecosystem that have been here for forever. It's pretty neat. We're lucky. It's a privilege to be out here. I think that's a good word. It's a privilege. When I finished my PhD, I felt like I had to relearn this place. So I spent the first 6 months just going up and down the coast talking to resource managers. What are your big problems? What do you manage that has to do with birds and water that I might be able to help you with? And that's when I sort of started to hear the same thing over and over again. Like these islands that are so important to these birds, they come together, these colonial water birds, and they nest in very few places spatially. It's not a lot of area covered. But while they're nesting, they're really vulnerable. And what's been changing is that these islands have been getting smaller. Managers told us they were disappearing, but they didn't really know why or how fast. And first step was to say, well, let's find out how fast. And so we did a study. They're absolutely right. We're losing 2 to 3% per year of these islands. So run that out 30 years. These islands are, some of them have gone underwater in the period that we were studying them, that fast.
In the past, one had to be careful navigating the water. When I left the mouth of St. Charles, there was a reef out there called Thompson's Towhead. And the crest of that reef was right at the surface of the water on the normal water level. And you really couldn't see it because it was small. But if you hit it, you had a problem. And it's totally gone. But that's just one of many.
Waves are typically what causes the erosion. It's wind waves from just the wind blowing over water generates the waves. Storm events will come through. You have boats also. Boat wakes can have an impact on that because, it's still a wave and it's still going to come, it's going to break and cause the same function along a shoreline. There's other issues. There's not as much sediment that reaches the coast anymore. Dams that are on rivers have impacts on sediment that's able to flow down to the coast. Structures at inlets where you have jetties and an inlet to help provide stability for navigation. Well, that affects the transport of sand. And then also even changes in water level. So sea level rise happens if it happens at an increased rate as well. There's more water, maybe it's going over reefs or over other structures and then getting back up into areas where maybe it hasn't hit before. So it's just a litany of things that happen that causes erosion along our shorelines.
We know because of the measurements that we as surveyors are taking of water levels on the coast that water levels are rising. And we also know that erosion is increasing, like we're seeing increased erosion all along the coast. The link to oyster reefs isn't obvious.
We have to come back to the basic tenets that we've developed of what does an oyster reef do? What is the value of that reef? And one of them is vertical relief. We need to focus on what is vertical relief? What is the relationship of that aspect of a reef life to the whole resource? And what's being done to it? Vertical relief, by my understanding, is the height of the crown of the reef above the surrounding bottom, which that height and that structure creates, in essence, a levee. There are baffle reefs that go from the barrier island to the mainland, and then there are freestanding reefs that are out in the bay itself. But all of those are levees in the movement of water and determine the speed, the direction, the volume of water that goes through an area. If you do not have those reefs there, then a surge of water, whether it's coming from a cold front or a low pressure system where we have a storm in the Gulf and this surge of water comes in here and gushes through, if you don't have something to slow that down, then the rate of erosion on the shoreline becomes out of control.
Oyster reefs and bays, they're, especially if they grow and they go into the intertidal zone, when they're getting up into an area where they're knocking down a lot of that wave energy, and then you can see that it's calm in there. Coral reef does the exact same thing out on the ocean coast. The vertical relief is a huge component for the ability of the reef to break up that wave energy. As we get these reefs that grow, particularly close to shore, they're going to provide that same impact. They're going to break up wave energy.
Oysters improve water quality through filtering our bay water. And when you have improved water quality and improved water clarity, then you have an increase in the amount of vegetation along shorelines, and that vegetation functions to hold the soil along the shoreline in place with its root system. As you decrease vertical relief, the natural benefits that reefs provide are all diminished. You would get less attenuation of wave energy, you'd get more turbid waters because the reef doesn't have the filtration capacity that it used to, and then you'd also have much less robust buffering of major storm events. I think there's three primary ways that oyster reefs have their vertical relief reduced. Sea level rise changes the vertical relief of the reef relative to the bay bottom. The reef may be the same height, but it's getting overtopped by waves because sea levels are increasing. Major storm events like hurricanes can overtop reefs, take the crest off. It can scatter oyster reefs. Harvesting certainly decreases both the shape and the vertical relief of oyster reefs, and we've seen vertical relief diminished over the decades that these reefs have been harvested. The long-term effect of wild oyster harvest is to physically scatter the reef. As our reefs are both diminished in height and shape, the structure and the strength of the reef is also diminished. If the reef is over-harvested and the side slopes go from long and flat to more steep, that reef is essentially destabilized. And during a high energy event, like high winds or a hurricane, that reef can be physically displaced or degraded more than, or eroded or scoured more than it naturally would be, because it doesn't have the side slopes there, giving the reef the structure and stability. If you're looking at a given piece of shoreline, and if the smooth cordgrass or mangroves or shoal grass that would naturally grow along that shoreline has been depleted, and the shoreline is just being actively eroded, the only way to protect that shoreline is to build, a man-made physical structure like a breakwater. I've noticed that the bar reefs have a similar dimension or structure to your breakwaters, so they have side slopes and they have a crest.
I think we're getting the idea of a breakwater from emulating nature. We're again doing this to provide protection to the area and the marsh and stuff that's behind here. And you can see along the front edge of here where the water level gets up to, and you can see where there's constant smashing of the rock. And you can see the different color in the rock. And then we have that white crest. So as the waves come, they're breaking on this first part. If it even goes over the top, it's breaking over, and then we're losing that wave energy as it gets back to the backside.
There's research out there that shows that reefs actually self-build at a rate comparable to sea level rise. So left alone, the reefs can sort of keep up, but if we're doing things to impact reefs negatively so that they can't self-build and keep up, then we're changing, that's setting into effect a cascade of events of all these other things. It's not just the reefs we're talking about here, it's the whole ecosystem. And because of that, I've sort of arrived at the conclusion that because oyster reefs and the associated vertical relief have all of these ecosystem, habitat, energy, there's just all these different effects they have, reef height could be a primary indicator of the ecosystem health. I was privy to some of the total construction budgets on some of these projects, and restoration of any kind is inherently extremely expensive.
And you can see those costs going up, and it's just due to all a number of factors of fuel's more expensive, and getting a rock is expensive, labor is expensive, just all of these things come into account.
It's bigger than erosion. I think what's at stake here is literally the viability and health of the Texas coastal ecosystem. I think that the health of oyster reefs is one of the primary components of like the health of Texas bays from Brownsville to Sabine Pass. The research clearly shows that reefs that have vertical relief are healthy and those with diminished vertical relief are unhealthy. If we allow the oyster reefs to continue to be over-harvested and impacted the way they have been for the last few decades, we're going to start seeing accelerated water quality and erosion and other issues that'll spell the demise of our bay systems. We need to work very hard to ensure that the oyster reef morphology, the shape and the height that's there is preserved because it's providing critical function that we can't afford to replace.